Hello and good morning to all of you. I hope all of you are doing well and all of you in good health. So, in today's class, we'll be starting with the fundamentals of computer organization and architecture. Now, a computer is a programmable finite state electronic device that is capable of performing arithmetic and logical operations on the values that are provided to it as input in order to generate certain purpose specific output values based on a set of well defined instructions. Now, a computer is called as a programmable device because it can be instructed to perform user-defined operations, whereas a computer is called as a finite state machine because the range of values the computer system works with is always predefined. So these are the two fundamental properties of a computer system. So again, I'll repeat it. So a computer is a programmable finite state electronic device that is capable of performing arithmetic and logical operations on the values that are provided to it as input in order to generate certain purpose specific output values based on the set of well defined instructions. Now let us try to understand a computer with the help of a very neat block diagram. Now if you observe this particular block diagram, you'll find that there are several interacting units that are collaboratively capable of realizing the operation of a computer system. So here we have input unit, we have output unit, we have memory unit, we have central processing unit, wherein we have control unit and arithmetic and logical unit. Now let us try to identify the roles of the individual units. Now input unit to begin with. So input unit is a unit that is capable of communicating data and instruction from the user to the computer system, right? So if you see, input unit is a unit that is capable of communicating data and instruction from the user to the computer system. So the data and instruction that is read by the input unit from the user is placed in the memory, which can be later used in order to perform the desired operation. Now some of the examples of input unit are keyboard, mouse, light pen, and so on and so forth. So there might be several examples of input unit. Now, once the program has been once the set of instruction and data has been read and placed in the memory, now what we need to do is we need to perform operation on that particular data using the instructions, right? Again, now that is performed by the central processing unit. Now, central processing unit performs various tasks. The tasks includes execution of instruction in sequence, and input-output operation, as well as coordinating the activities of all the other units. So just see, these are the activities that are performed by central processing unit. So the central processing unit performs the task of executing instructions in sequence and IO operations. It also performs the task of coordinating the activities of all the other identifiable units. So it's also referred to as the brain of the computer system. Now, central processing unit has two identifiable units, as we all know. These are called as control unit and arithmetic logical unit. Now, control unit is a unit that is responsible for coordinating the activities of all the other units. Right? So the control unit is the circuitry that controls the flow of data through the processor and coordinates the activities of all the other units within it. So it is called as brain within the brain, as it controls what happens inside the microprocessor, so which in turn controls the rest of the computer system. So this is the role that is performed by control unit. Now arithmetic logical unit, as we all know, is a unit that is capable of performing arithmetic logical operations. Now arithmetic operation basically includes addition, subtraction, multiplication, division, and in some of the advanced microprocessors, we perform floating point operations as well. And the logical operations includes and, or, not, and XOR. Now, memory unit. Now, memory unit is a unit that is capable of storing instruction and data that is to be processed by the microprocessor or the central processing unit. Now, computer memory is made of semiconducting devices such as silicon, and it's capable of storing information in binary form, that is in forms of zeros and ones. So the binary number consists of two digits, as we all know. These are zeros and ones, each occupying one bit of memory space, right? So I 0 or 1 occupies 1 bit of memory space. So a group of 8 bit is called as a byte, and with each and every byte an identifiable tag is associated. This is called as an address. So you see, with every byte of memory, what we have is we have an address value that is assigned. Now let us try to learn some of the notations that are used for representing memory. Now 1 bit is capable of representing a binary digit, either 0 or 1. 1 nibble is a collection of 4 bits. 1 byte is collection of 8 bits. 1 kilobyte is collection of 1024 byte. 1 megabyte is collection of 1024 kilobyte. 1 gigabyte is a collection of 1024 megabyte. 1 terabyte is a collection of 1024 gigabyte. 1 petabyte is a collection of 1024 terabyte. 1 exabyte is a collection of 1024 petabyte. 1 zettabyte is a collection of 1024 exabyte. 1 yottabyte is a collection of 1024 zettabyte. 1 brontobyte is a collection of 1024 yottabyte. Likewise, 1 geobyte is a collection of 1024 brontobyte. So these are some of the standard notations used for representing collection of bits. Now, let us progress on with the types of memory. Now, there are different types of memory that a computer system may have in it, which are used in order to store the instruction and data. Now, these memory cells can be broadly classified into two categories. One is called as on-chip memory and the other one is called as off-chip memory. So on-chip memory basically means memory that is there within the microprocessor, whereas off-chip memory is called is the memory that is placed that is outside the microprocessor. Now let us try to understand different types of memory and the utility of different types of memory. Now the first type of memory that we have is called as CPU registers. Now CPU registers are example of on-chip memory, right? Okay, so a processor register is a small amount of on-chip storage available where the data is stored temporarily during processing. Now, computer loads data from larger memory into register, which holds it during arithmetic and logical operation during the execution of a machine instruction cycle. So, this is the role of central CPU registers. So, CPU registers are onboard memory, which are capable of storing data temporarily during processing. So, data from the slower memory is copied into the CPU registers during any arithmetic or logic execution of any arithmetic and logical operation. Now internal cache. Now internal cache is a high speed on-chip memory again. So internal cache is again high speed on-chip memory that contains frequently used data by the microprocessor. Now the reason why do we need to have an internal cache is to avoid repeatedly reading data from slower main memory. So again what we need to do is we need to communicate through the data bus to the main memory and again bring the data. So in order to overcome that particular hurdle of reading the data from a slower main memory, we have a high speed onboard memory which is capable of supplementing the register, which is capable of holding frequently used data during execution. Now likewise we have external cache. Now external cache is a high speed off-board memory that is used in order to supplement internal cache. So this is the purpose of external cache. So external cache is a small high speed off-chip memory that is used in order to supplement internal cache, and it performs the role of internal cache when internal cache is not present. Now main memory. Main memory is used in order to store data and instruction that are used by the microprocessor to perform operations. So this is the role of main memory. So main memory is a memory that is used in order to store data and instructions that are used by the processor in order to perform operation. But main memory is a volatile piece of memory, which implies if the power is turned off, the content of the memory will be flushed. Now secondary memory. So now secondary memory is the slowest of all the memories that we have, and it's the cheapest form of memory. So it cannot be accessed directly by the microprocessor or the central processing unit. So it has to be done through the main memory. So any data that has to be used by the microprocessor in order to perform operation that is present in the secondary storage has to be first brought to the main memory, and from main memory then it will be subsequently communicated to the central processing unit through other forms of memory. So secondary memory device includes magnetic disk like hard disk and floppy disk, optical disks such as CD-ROMs and CDs and CD-ROMs, and magnet tapes. So these are some of the examples of secondary memory. So here we have a very simple graphical representation of cost versus speed as well as cost versus size. Okay, right? So registers are expensive compared to that of internal cache. Further, external cache, main memory, and secondary memory is the cheapest version of memory that we have in context to speed. So greater the speed, greater will be the cost. Now likewise, we have size. So the cost per unit size is very large in case of registers, whereas it's very low in case of secondary memory. So this is a very simplified graph that tries to show cost versus speed and cost versus size representation of the various types of memory that a computer system may have in it. Now output unit. Now output unit, as we all know, is a unit that is capable of communicating information from the computer system to the user, right? Because after performing an operation, the microprocessor will be capable of delivering certain desired outcome. So that desired outcome has to be communicated to the user. So it is done through the output unit. So monitor and printers are typical example of output unit. Now we have different types of computers. We have analog computers and we have digital computers. So to discuss analog computer and digital computer in brief, so analog computer is a form of computer that uses continuously changing aspect of physical phenomena such as electrical, mechanical, or hydraulics quantities to model the problem being solved. Whereas in case of digital computer, a computer that performs calculation and logical operation with quantities represented as digits using usually in form of a binary number system. So that's the identifiable difference between a analog computer and a digital computer. Now let us try to go through some of the important characteristics of a computer system. Now the first characteristics of a computer system is speed, then we have storage, we have processing ability, right? We have accuracy, we have communication, and so on and so forth, right? So these are some of the important characteristics of computer. So a computer system, as we all know, works at a very high speed, and it's much faster than that of a computer system, which implies even a second is a very large time period for a computer system. So a computer can perform billions of calculations in seconds. So now we have advanced computers that are capable of performing millions and billions of instructions or execute millions and billions of instructions per unit time. Now the time used by the computer to perform an operation is called as the processing speed, right? So computer speed is always represented in terms of hertz, megahertz or gigahertz. Likewise, storage. A computer can store large volume of data permanently or temporarily. Now user can use this data at any point in time in order to perform operation, right? Or in order to create a certain suitable representation. So data can be in forms of text, graphics, pictures, audios, videos, and so on and so forth. So now what we have is we have computer systems with greater capacity in terms of storage. Likewise, processing. A computer can perform process a set of given instructions, right? So it can perform different types of processing like addition, subtraction, multiplication, division. It can perform logical operations like AND, OR, and NOT, and XOR, right? So computer performs various types of processing. So it performs arithmetic and logical operations, right? Okay. Likewise, accuracy. So accuracy basically means to provide the result without any error. So this is one of the important characteristics of a computer system. So a computer can process large amount of data and generate error-free results. So a modern computer performs millions of operations in 1 second without any error. So this is what accuracy is all about. So this is one of the important characteristics of a computer system. Now likewise, compute communication. So most computers today have the capacity or capability of communicating to other computers with the help of computer networks, right? So we can connect two or more computers by communication devices such as modems, right? So these computers can share data, instruction, and information. Now the connected computers are called as network computers. So in today's class, what we have learned about is we have learned about what is a computer. We have learned about what are the fundamental properties of computer. We have learned about computer with the help of a block diagram. We have identified various identifiable units that are capable of collaboratively realizing various operations that are related to a computer system. We have learned about the role of input unit. We have learned about the role of central processing unit. We have learned about the role of control unit. We have learned about the role of arithmetic logical unit, and subsequently we have learned about the role of memory unit as well as output unit. Okay, output unit, right? So output unit here. And we have also discussed different types of memory, which includes CPU registers, internal cache, external cache, RAM, ROM, and secondary memory, right? And we have also seen a cost versus size and cost versus speed representation of different types of memory. Then we discussed the basic difference between analog and digital computer, right? Okay, and subsequently we discussed the characteristics of computer, highlighting speed, storage, processing accuracy, and communication as some of the important aspects, right? So thank you very much. Have a very nice day.